Okay, some more Avogadros Law Practice questions. These two are labeled as challenge questions, but I think that you will be just fine in solving them. You just have to pay a little bit more attention to the different units that you're given. So here we go. Number 5. A hot air balloon is inflated with 22,854 grams of helium. So let's go ahead and underline that. That's our first thing, and that is going to represent N1 because that's our amount. It's not in moles, though, so that's what you got to pay attention to. As it is flying across the ocean, a hole is punctured in the balloon, and it is forced to crash land on an island. The captain measures the deflated balloon's volume at 192 liters. Its original inflated volume was 896 liters. So those are our two volumes. We've got to figure out where they go, though. How many moles of helium are in the deflated balloon? So our V1 and N1 right here, these are both going to represent the inflated balloon. Our V2 and N2 are going to represent the deflated balloon. So a balloon is inflated with 22,854 grams of helium, so that's going to be N1. Then we look here, its original inflated volume was 896, so that's going to be V1 because the inflated numbers have to go together. The deflated balloon, let's change that to blue. The deflated balloon right here, 192 liters, so that's going to be V2. Do we have the deflated balloon's number of moles? No. Are solving for how many moles of helium are in the deflated balloon. So that is going to be our N2. That's what our unknown is. Now, the first thing you have to do here, a little bit different, because we have to convert from grams to moles, because we're given grams of helium. So we have to do 22,854 grams of helium, and we have to convert that using wonderful dimensional analysis to get to moles of helium. Now, how many grams are in 1 mole of helium? That's when we look at its molar mass. Look at our periodic table. We see that 1 mole of helium is 4 grams of helium equals 1 mole. So then we simply multiply across. We end up just doing 22,854 divided by 4. So let's figure out what that is. 22,854 divided by 4. That means we have a large number of moles. We're going to end up with 5,713.5 moles of helium in our inflated balloon. Okay, now that we've converted that to moles, now we can set up our ratio using Avogadros law. So V1 over N1 equals V2 over N2. We already identified our V1 is 896, so 896. Our V2 is 192, and then our N1 we just solved for is 5713.5, and then our N2 we don't know. That is what we are solving for. So we have this over this, this over this, and they are set equal to each other. And we're solving for the number of moles in the deflated balloon. So we will cross multiply. All right. 896x equals, and this is going to be a pretty big number here because we have 5,713.5, and you multiply that by 192, and that's going to give you 1,096,992. It's a huge number. So what we do next, of course, we divide by 896, divide by 896 to get the x by itself. 896, 896 divided by 896. My final answer in terms of how many moles of helium are in my deflated balloon, this is how many were in the inflated balloon. My deflated balloon only contains 1,224.3 moles. That is my final answer. Got that? Well done. Good challenge question right there. Proud of everybody. Success. That is how many moles are in my deflated balloon. One more challenge question. All right. A man is trying to break the world record for the longest free fall back to Earth. When he gets to the edge of the atmosphere, he falls off his plane and back to Earth's surface. His parachute is originally deflated in his pack. In its deflated state, its volume is 852 milliliters. So we're going to do deflated as V1N1, and then inflated as V2N2. Sound good? Sounds good. And it contains 64 grams of oxygen gas in its deflated state. So we have our V1 right here, and we have our N1 right here. After he falls and the parachute inflates, it now contains 896 grams of oxygen gas. So inflated contains 896 grams of oxygen gas. So that is going to be our N2. If measuring in liters, what is the volume of his inflated parachute? So we are solving for V2. This one, you should have noticed first that we have to convert to liters and we have to convert to moles. We have to do a lot of conversions here, so we'll just try to roll through them quickly. 852 milliliters. There are 1,000 milliliters in 1 liter. Therefore, to get the number of liters, we would just do 852 divided by 1,000. So our V1, 852 divided by 1,000, just, clarifying the calculator, 852 divided by 1,000. 0.852 liters in its deflated state. So that is going to be our V1. Our V, well, we'll just go ahead and let's circle this as our V1 so we don't forget it. Circle it in purple. This right here, 852 liter, 0.852 I should say, liters is our V1. Let's get our N1. To get our N1, we have to convert grams of oxygen gas into moles of oxygen gas. So we start off with 64 grams. Set up our dimensional analysis here because everybody loves dimensional analysis. In 1 mole of oxygen gas, because it's O2, it is 32 grams of oxygen gas in 1 mole. 64 divided by 32, that means we have approximately 2 moles of oxygen gas in our original deflated parachute. So that is going to be our N1. This is our V1. Now let's quickly get our our N2, because we don't know our V2. So for our N2, same process. We have 896 grams of oxygen gas. So we'll go through the dimensional analysis again. 32 grams of oxygen gas goes on bottom right here. 32 grams under, I should say, 1 mole. 896 divided by 32 is going to give us how many moles we have for our N2. So 896 divided by 32 equals 28. So we have 28 moles O2. That, keep the colors consistent here. This right here is going to be our N2. So that was a little bit of a process. You just have to make sure you have all the conversions correct. So now we can set up our equation here. We have V1, 0.852. We have V2. We don't have V2. That's our unknown. We have N1, which is 2 moles. Give us a little more space here. And then we have our N2, which is 28 moles. So we set up our, let's use black here. We set up our ratio here using our formula that we've used so well so far. And then we will cross multiply 0.852 times 28 and x times 2. You end up with 2x, not x, s, x. 2x equals 0.852 times 0.852 equals 23.9, rounded, of course, 23.9, and then we simply divide by 2. Divide by 2. Divide by 2. 23.9 divided by 2 equals about, we're just going to round here, to 11.9. What we were going to measure in, what were we solving for? Go back to the problem, make sure we know what we were solving for. We're solving for V2. Therefore, it's going to be 11.9 liters in our inflated parachute. Hopefully you got that. If you did, congratulations. Well done. Those are our 2 Avogadros Law challenge questions. Farewell.